All right, so we talked about this just a second ago. Pythagorean theorem, a squared plus b squared equals c squared. And I think, like, out of everything in geometry, most people walk out remembering that. But just a couple of clarifications. C has to be the hypotenuse. The other two, it really doesn't matter what order you put those in. C has to be the hypotenuse, the biggest side. And it only works for right triangles. If you don't have a right triangle, this goes out the window. Okay, all on the same page? Otherwise, you're just going to use the formula, but you have to be able to reduce your square roots. Okay, so looking here, this is the side we're missing. I'm going to call it A. Okay, so we will have a squared plus 4 squared equals 10 squared. And if you're like, hey, this feels like geometry class. Yep, not any different. You just don't have a calculator now. All right, so that'll be a squared plus 16 equals 100. And then what? This is like back to our algebra. Minus the 16, you would get a squared equals 84. And then we're going to square root. Now you would have to split square root of 84. So I think 4 goes into that, right? It'd be 4 times what? 21. Yep. And so what would be like the final answer? 2 square root of 21 is your final answer then. I'm going to put those in another color so you can see it better. You'll be okay. Didn't I put that on post? Yeah, look, you're going to be okay. All right, how do we set up this one? It would be... You can call it A or B. I usually just go with A, given the choice, just to be consistent. So a squared plus 7 squared equals 15 squared. It is 225. 15 times 15 will be 225. Then we're going to subtract 49. I don't know what that is off the top of my head, so I'm going to come over here off to the side and do 225 minus 49. You guys remember how to borrow?
Oh yeah, you got like cross one out.
176. You know what? Every once in a while, you have to do that. Like every once in a while that, you know, you got to do a little side problem. I was like, hey, I can't do this in my head. So I came over here and wrote it down. All right, and then we're going to square root. Now, I wouldn't give you something this large on a test. So I am going to pull up the calculator so you can see here. Let's try 176 divided by, think of a perfect square you want to guess goes into 176. Let's try. 9. That's a decimal. 176. I heard somebody say something. What'd you say back there? Because I think it might be 16. 11. 16 and 11. Good. So you're going to split it into square root of 16, square root of 11. And so then what's your final answer? Yeah, 4 square root of 11. So like there are certain things I think you should be able to do without a calculator. And if you can't do it in your head, you should do a side problem. But I don't expect you to walk around knowing all the numbers that go into 76. Like you could have a calculator for that. Okay. Now this next one, 5 squared plus 12 squared would equal c squared. You do need to call that c since it's the hypotenuse, but I'm going to go ahead and tell you it's 13. There are these things called Pythagorean triples. I call them the locker combination ones. And there's a few that you should actually just know, and it'll make your life easy. The first one, and I'm just going to write them off to the side here, is 3, 4, 5. 3 squared plus 4 squared equals 5 squared. So for example, if you see a triangle like this, what's x without any work? 3. Do you see how that makes your life easy? If you see one like this, what's x? Without any work. Do you see how that works? Okay, and then there's a few more that I think we should just know. There's 4 of them that I usually just tell everybody they should know. 5, 12, 13 is the next one. We've got 7, 24, 25. And 8, 15, 17. Just maybe like put a box around that and draw some stars or something. If you just know those ones, it will make your life so much easier. Again, here's another example. This is what I'm saying. If you see this, what's the answer with no work? Do you see how that makes your life easier? 7, 24, 20. Like if you see this one. 17 with no work, just trying to save you some work. Okay, so if you know, I call them the locker combination ones. If you're like, nah, I'm not going to memorize those, Miss Cole, that's fine. Can you at least give me 3, 4, 5? Can you give me that one? At least see that one. Okay. Now we're going to do our special right triangles. So these are 2 like special cases. Does 45, 45, 90 ring a bell? Like we did. Okay. So what that means is 2 of these angles are the same. What kind of triangle is that? This is a piece of vocabulary you guys shouted out to me. If 2 of them are the same, it's isosceles. Here's 45, here's 45. And so these 2 sides are the same. Or congruent. Do you remember the word congruent? So instead of ABC, we get AAC. They're the same. So when you do your Pythagorean theorem, instead of a squared plus b squared equals c squared, you get a squared plus a squared equals c squared. Again, because they're congruent, they're the same. And we're going to kind of go through that and see where it takes us because we want a formula to be able to do these quickly. A squared plus a squared would give you 2a squared. We're just putting those together. And then what could we do to both sides to like simplify that further? Square root to get rid of the squares. Now, if you're like, hey, what about the plus and minus? Good news. You don't have to worry about that with trig because everything is triangles. And why don't we have to worry about a plus minus? You can't have a negative side of a triangle. Like everything is going to be positive. Isn't that great? So I told you the second half of the year is easy. Everything's triangles. Okay. So when you square root of 2 is just square root of 2. There's really nothing we can do about that. But what happens with the square root and the squared here? They cancel or undo each other. So you have square root of 2 times a equals c. So that's your little formula to get from the smaller side to the bigger side. You would just multiply by square root of 2. Question. To get from here to here, you multiply by square root of 2. To go the other way, you would divide by square root of 2. So if you take the bigger side c and divide by square root of 2, you're going to get the smaller side. So you either multiply or divide by square root of 2. We're going to come down here to these examples and just do the 45, 45, 90 ones so that I can show you how this works. You either multiply by square root of 2 or divide by square root of 2. That's all it is. So looking at this one, do you see how it's a 45, 45, 90? You have to establish that first. Do we have one of the smaller sides or do we have the bigger side like the hypotenuse, the 18? That's the smaller one. Because do you see how it's across from the 45? These aren't to scale. All right, not going to be perfect. Not going to get out a protractor and measure these. So if this is 18, what is this side? 18. Wasn't that easy? And then to get to the bigger side, you multiply by square root of 2. So if these are both 18, what's the hypotenuse? Don't overthink it, guys. Okay, let's back up. You're going to multiply by the square root of 2. So if these are 18, this would be 18 square root of 2. That's literally it. Let me make up another one up here real quick. All you're doing is multiplying by square root of 2, guys. Don't overthink it. Look it. Do you see how this is a 45, 45, 90? You have to establish that first. Give me a number. 3. 3. Say this is 3. What's this then? 3. 3. What's this then? Let's try it again. Is this a 45, 45, 90? Yeah. Establish that first. Give me a small number. If that's 7, what's this?
7.
And then this is,
7.
we cool? Okay, now if you want to go the other way, instead of multiplying, you will divide. Okay, so do you see how this is a 45, 45, 90? But we have the hypotenuse this time. So I'm gonna need to like do a little side problem. I'm gonna take 18 and divide it by square root of 2. And then you have to rationalize that. So it would be 18 square root of 2 over 2. And then you reduce the fraction. 18 divided by 2 is 9. So if this is 9 square root of 2, that means this side is 9 square root of 2 because they're the same. I'll make up another one. That's the other nice thing about these problems. I can just make them up all day long. Like it's just triangles. Give me a little number. 4. That's the big side, right? The hypotenuse. You're looking at me here. So to get to the smaller side, we're going to divide by square root of 2. Rationalize that. It would be what? And then reduce. 4 divided by 2. If that's 2 square root of 2, this is 4. All right. Does 30, 60, 90 ring a bell? Do you remember that as our other like special one? Okay. So you're going to have a smaller side and a bigger side. Here's our 30 degrees. Across that, I'm going to say, okay, that's A. Here's our 60 degrees. Across from that, I'm going to put B. And then C is the hypotenuse. So unlike with the 45, 45, 90, where you had 2 angles the same and 2 sides the same, now they're all different. So this one is a little bit more complicated. Okay, you have a small side, a big side, and then the hypotenuse. So what I'm going to do to show you this one is draw in the mirror image of that triangle. So like kind of dot that. Do you see how it's like the same thing? Just like a mirror image, like I flipped it over. Okay. So if this amount is A, follow me here. If this amount is A, what is this amount? It's also A. And if I've made all of these the same, if this side is C, this side is C, and that means this entire side is also C. Like I made it equilateral. So what's a formula to get us from A to C? Do you see how I have A here and C is the whole way across? So A plus A is C, but can we do that a little differently? Because that's true, but it would be 2A equals C. So if you multiply by 2, that'll get you from the smaller side to the hypotenuse. So let's say you had to go backwards. Instead of multiplying by 2, you would divide by 2. So C divided by 2 will give you A. These are really the same formula. I'm just writing it both ways so that you can see what I'm talking about there. Were y'all still together? You either multiply by 2 or divide by 2. You multiply when you're trying to get from the smaller one to the bigger one. You divide when you're trying to get from the bigger one to the smaller one. Okay. Then we're going to set up our Pythagorean theorem. A squared plus B squared. Now I know it would be C squared, but what did we just say that C equals? 2A. So I'm going to write it as 2A squared. It's A squared plus B squared equals C squared, but C is this 2A. And then we're going to work that out and see where it takes us, and that's going to give us our formula. So A squared plus B squared equals, you have to square the 2 and the A. So what is that going to give you? Be 4A squared. And then you want to get the A's together. So what would you do with this? Yeah, move it. You would subtract, right? So you would get B squared equals 3A squared. 4 minus 1 gives you 3. And then we're going to square root. So you would get B equals, and then what's this going to give you over here? Square root of 3 times a. So if you want to get from the smaller side to the bigger one, you're going to multiply by square root of 3. Remember over here, we multiplied by square root of 2? So it's just a square root of 3. If you want to go backwards, instead of multiplying, you will divide. These mean the same thing. I'm just writing it both ways so that you can see it. We're going to do these 3 examples, and then I can make up a zillion more if you need. Don't stop listening to me. If we do these 3 and you kind of need some more to get the hang of it, what happens is everyone sets down their pencil and starts looking at something else. Don't ignore me. Like, I'm going over it for your benefit, okay? Do you see how we have a formula to get from A to C and from A to B? You can't go directly from B to C. That doesn't exist. You have to go to A first. Following me here? Okay, you can't go directly from B to C. So looking down here, have we established it's a 30, 60, 90? Okay, so that's the first thing. You have to see that it's a 30, 60, 90. And then think about which side you have. Do you see how the 18 is across from the 60? That means it's the bigger side. That means it's B. The triangles aren't to scale, right? They don't look perfect, like it's not to scale, okay? So we have the bigger side. To get to the smaller side, we're going to divide by square root of 3. So what would that give us when we rationalize it? It's 18 square root of 3 over 3. And then you reduce the fraction. Good. So this would be 6 square root of 3. So we divided by square root of 3. Now to get from this smaller side to the hypotenuse, you're going from a smaller one to a bigger one. So you're going to multiply. What do we multiply by for that? 2. You're going to multiply by 2. So take this, multiply it by 2. You're really just doing 6 times 2. 12 square root of 3. You just did 6 times 2. Let's try it again. Do you see how this is a 30, 60, 90? Like you have to establish that first, okay? Which side are you given? Like this 18 is where? C, it's the hypotenuse. How would we get from the hypotenuse to the smaller side? Hint, you're going to have to divide because you're trying to make it smaller. Divide by 2. 18 divided by 2. That side is 9. And then how do we get from the smaller side to the bigger side? We're going from a small one to a big one, so you're going to have to multiply. What do you multiply by? Look back. Square root of 3. If you do 9 times square root of 3, guess what that is? 9 square root of 3. Do you see how this is a 30, 60, 90? That's the first thing, okay? Which side are you given? A, it's across. Do you see how it's across from the 30? It's across from the little one. How would you get from there to the hypotenuse? You're going to have to multiply because you're trying to make it bigger. From here to here. You're going to multiply it by 2. So 18 times 2, 36. To get from here to here, you're going to multiply again, but this time by... So 18 times square root of 3 is 18 square root of 3. So go ahead and flip that over. And here's our trigonometry. So like I said, for the Pythagorean theorem as well, sine, cosine, tangent only work for right triangles. If it's not a right triangle, this all goes out the window, okay? And I am, of course, going to tell you, but I want to see if anyone remembers this from geometry. And I'll give you a hint. It's something over something. Like these are all ratios. They're all going to have like a fraction bar in it. Oh, this is opposite over hypotenuse. Good. There are a zillion ways people remember this. You can go with whatever works for you. There's like 100 different acronyms people use and sentences they use to remember this, whatever works for you. The most famous, I think, being SOHCAHTOA. Oh, is that ringing a bell? Okay, so what is cosine? What over what? Adjacent over hypotenuse. what does the word adjacent mean?
Um,
Like next to, okay? Opposite means across from. And then this is the TOA part, so opposite over adjacent. Again, it only works for right triangles. That's all I have to say about that, okay? So we're gonna find the missing stuff, so like where the X is. What you have to be careful about is your point of view. Like the "you are here" star on a map. I always say that every year, like the "you are here" star, but you guys don't use maps anymore, right? Because we all have like GPS now. Do you know what I'm talking about though? Like if there's a map and there's a star on it, it's "you are here." Like I guess at the mall I can have that sometimes. Anyway, the "you are here" is the angle that's labeled. So do you see how this 37 is the angle that's labeled? This is your point of view. You are here. Okay. So X is the hypotenuse and 11 is the what? It's the adjacent. The opposite would be this one. Do you see how 37, if you draw an arrow across, this would be opposite? I'm not going to bother labeling that though, because I don't have that piece of information. So look, if you have adjacent and hypotenuse, go back up here. Which one of these, sine, cosine, or tangent, involves adjacent and hypotenuse? Cosine. You're going to write cosine 37 degrees. You can't have sine, cosine, or tangent without an angle. Like it's sine of an angle, cosine of an angle, tangent of an angle. And by the way, I am going to correct you if you say sin, cos, or tan, because I have a very strong opinion that if you say it correctly, you will think it correctly, and therefore you will do the math correctly. Your words and actions are connected. Disagree with me all you want, I'm still going to correct you, okay? Cosine 37 equals adjacent over hypotenuse. So it would be 11 over x. Now you have to solve for the x. The problem is it's in the denominator. So what you would do is, and I'm going to go through these steps one time. After this, I'm going to expect you to just type it in the calculator. You would multiply the x to the other side. So you would have x times cosine 37. So you would multiply the x to the other side. And then how would you get the x by itself? Good. So what you're going to type in your calculator is 11 over cosine 37. I don't expect you to write that every time, though. I expect you to just look at this and type in your calculator 11 divided by cosine 37. No, don't type it yet. I have one other thing to say. And you're like, she's talking a lot. Well, got to give you all the instructions. First thing you're going to do is go to mode. It is right here next to the second button. Do you all see this? Mode. Do you see how radian is highlighted? And I'm going to teach you radians. That's what we're going to get into next unit. You don't want that though. You want degrees. I don't know how to tell you this, but if you aren't in the correct mode, literally all your answers are going to be wrong. Okay. So go down, put the cursor over degree and hit enter. Did everyone find that okay? Or need to calculate. Those are the exact same as these ones. If that bothers you, though, I'll trade you. They do the exact same thing. So are we in degree? Were you guys okay? We got to sort it out. Okay. So then quit out of there. You can just hit clear. Hit clear. It'll take you back to the home screen. And what you're going to type is 11 divided by cosine 37. 11 divided by cosine 37. It will literally just give you your answer. But how many decimal points do you need? 3. First 3 that you see. Now, I don't know what Delta Math does, so you're going to have to read their directions. I think a lot of the time they say to do 2 places, so just be careful with what they say. Anyone brave want to share? Perfect. 13.773. All right, let's try the next one. Do you see the 32 degrees that's labeled here? This 32 degrees? You are here. That's your point of view. You kind of have to pretend that you're standing there. So that means X is the what? Opposite. Good. 13 is adjacent. We don't have the hypotenuse. You can label that hypotenuse if you want, but I wouldn't bother because we don't have it. So go back up here. Which one of these, sine, cosine, tangent, involves opposite and adjacent? Tangent, good. So it's going to be tangent 32 degrees. Again, it has to be an angle, sine, cosine, or tangent of an angle, equals x over 13. Now to type that one in the calculator, that's a little easier because x is not in the denominator. You would just take the 13 and do what with it? Multiply it to the other side. So what you're going to type is 13 times tangent 32. And you can just put the 13 out front. So 13 tangent 32. Anyone feeling brave? 8.123. Oh, no. As long as I see the answer there, we're all good. Where's your point of view for this one? The A, 50.1. It's wherever it's labeled. So that means x is the what? Opposite? 5 is the adjacent. So do we want sine, cosine, or tangent? And I eventually want you to get to the point where you're not really labeling these. You're kind of just looking at it. But for right now, this is the first time we're going over it. So I'm going to label all of them. So tangent and then what? 50.1 equals x over 5. How would you type that? Good. What if, just a what if question, what if it was the other way around? What if this was 5 over x? Then how would you type it? 5 divided by tangent, blah, blah, blah. Okay, good. All right, so, but we are going to type 5 times tangent 50.1. Good. First 3 that you see, don't worry about rounding those. Just the first 3 that you see, 5.979. I'm going to give you, we're going to do this last one, and then I'm going to give you an extra problem just to try. So don't stop listening to me when we finish. We still have plenty of time at the end, all right? Where's your point of view? Where's the you are here? B, the 60 that's labeled. That means 11 is the what? Eleven's the hypotenuse. It's across from the right angle. We don't have the opposite. This would be the opposite. So x is the adjacent. So we have hypotenuse and adjacent. Look back up here, sine, cosine, or tangent. Which one has hypotenuse and adjacent? Cosine. So it's going to be cosine of 60 equals x over 11. And you would type 11 cosine 60. Again, if it was the other way around, you would do 11 divided by cosine 60. Now, if it just comes out to 5.5, you don't need to worry about the 3 decimal points. If you are nervous about that, you can type or write 5.500. I had a couple people do that on the test, but if that's the answer, that's just the answer. All right, we're going to do one more. Give me little numbers.
5.
I need something a little bit bigger than 5. I changed this one around. I didn't have one printed on here like this. Where did I put the variable this time? The angle. So the way you type it is slightly different when you want the angle. This is your point of view. This is the you are here. So 5 is the what? 5 is opposite. 7 is the hypotenuse. So look back. Do we want sine, cosine, or tangent? We want sine of x, because what we're looking for is the angle, equals 5 over 7. Now, when you want the angle, the way that you type this is second sign. Do you see how the sign right above it, it has sign with that little -1? Do you remember what the little -1 means? Oh, good, perfect. You guys are awesome. Inverse. So you're going to hit second sign and then 5/7. So when you want the angle, you have to hit sine inverse or cosine inverse or tangent inverse. Anyone feeling brave? Oh, it was almost a 45/45/90. So it's 45.584. And I won't mark it wrong because, for heaven's sake, you get the right answer. But what should you technically put with that since you found an angle? And the reason why I strongly recommend that is it will help you tell the difference between the side and the angles. It'll help you remember that. Okay.